67. The function fx equals half x squared plus 2x plus p. So there's a parameter p which is unknown. First question. But first of all, let us think about the general formula. Ax squared plus bx plus c. That's the general formula of a quadratic formula. A, in this case, is a half. B, this function is 2. And c equals p. Can I already tell something about my x vertex? It's minus b times 2a. So it's minus 2 divided by 2 times a half is 2 divided by 1 is minus 1. For which p is the graph entirely above the x-axis? Once again, I'm going to think about what I learned before. A graph above the x-axis. In this case it's half. A is a half, so it's a positive one. So it's a cup parabola. But when the graph is above the x-axis, that means that it's not touching or it's not intersecting the x-axis. In that case, my discriminant is smaller than 0. Now I just have to fill in. My discriminant equals b squared minus 4ac equals b is 2 squared minus 4 times a half times c is in this case p. So 4 minus 2p smaller than 0. 4 smaller than 2p. 2 is smaller than p. In this case, p must be bigger than 2. So when p is bigger than 2, then my parabola is not touching or is not intersecting, but it's above my x-axis. Question B. For which p does the graph of f pass through point A minus 8, 160? That means that f minus 8 equals 160. And I just can substitute the x by minus 8. So a half times minus 8 squared plus 2 times minus 8 plus p equals 160. A half times 64 plus minus 16 plus p equals 160. P equals 160 minus 32 plus 16 equals 144. So when p is 144 in this function, then it intersects or it goes through point A. Question C. For which p is the intersection point of f with the y-axis below the x-axis? Well, just think about it. When it would be a simple x squared, then I could say, okay, in that case there are 2 points of intersection, because then it's intersecting my y-axis beneath the x-axis. In this case I don't know, because it's not a simple quadratic formula. But I've seen that my x of my vertex is minus 1, so it could be somewhere here, and this could be minus 1. Now just interpret correctly the information. When the parabola is intersecting the y-axis, then my y has to be 0. So I could say a half x squared plus 2x plus p equals 0. At this position, the x is 0 as well. So I can fill in a half times 0 plus 2 times 0 plus p equals 0. So 0 plus p equals 0. That's only in one position when p equals 0. So when p is smaller than 0, then it's always beneath the x-axis.